Dear children, welcome to today's section. Children, in our last section, we were discussing about data structures, which are the different types of data structures. So, today, let's discuss list. Okay, before that, we can discuss which are the operations that we can learn on data structure. Operations on data structure. So see, different types of operations are insertion, deletion, searching, traversal, sorting and merging. Okay, insertion, deletion, searching, traversal, sorting and merging. Then first one, insertion. Insertion means addition of new data to a data structure. Second one, deletion. Deletion means removal of data element from data structure. Then third one, searching. That is search an element, that is finding specific data element in data structure. Next one, traversal, processing all data elements one by one. Okay, that means visiting all elements. Okay, processing all elements. Next one, sorting. Sorting means arrangement of data in a specific order. You can arrange these elements either in ascending order or in descending order. And last one, merging, combining elements of two similar data structure to form a new data structure. Okay, so these are the different operations on data structure. Clear? The next, our first one is linear list. So you already know a list is a set of elements, set of finite number of elements, and all should be a same type of elements. Then the same type of elements are called homogeneous elements. Okay, now let us move through the points. The first point is a linear data structure forms a sequence. Then second one, when elements of linear structure are homogeneous and are represented in memory B, means of sequential memory locations are called arrays. Okay, then third one, an array stores a list of finite numbers of homogeneous data elements. The next one, when upper bound and lower bound of linear list are given, then a size can be calculated as size of list is equal to upper bound minus lower bound plus 1. So here we have one example. Okay, so here 7 elements are given. Okay, 1, 2, 3, 4, 5, 6, 7 elements are given, and the memory locations will be given as 0, 1, 2, 3, 4, 5, 6. Okay, then to find the size of a list, here the upper bound is equal to 6 and the lower bound is equal to 0. So to find the size, you can do upper bound minus lower bound, that is 6 minus 0 plus 1. So you will get size of a list. Okay, so linear list is an array. An array stores a list of finite number of homogeneous data structure. Okay, homogeneous means same type of elements. If your array type is integer, then all elements should be integer. Okay, if your array is a floating point array, then all elements should be floating point number. That is the meaning of homogeneous data structure or homogeneous array. So in this array, the first one is searching. Okay, linear and binary searching. Okay, so today I will discuss how to do linear searching and binary searching. Linear searching means each element of linear list is compared with the given item to be searched one by one. This method traverses the linear list sequentially to locate the given item. Okay, for linear searching, item need not be in any order. It can be performed on a random list. Linear searching is suitable for small list only. Then which is the best case, worst case and average case. Best case is that when the item to be searched is at first position. Okay, the searched element is located at the first position. So this one is the best case. Then the worst case is that when item to be searched is at last position or not present. The average case, when item is somewhere in list other than first or last position. Okay, so this one is called linear searching. Okay, children, so in linear search, no need to perform any sorting. That means you no need to arrange the set of data in ascending or descending order. Okay, then linear search, the search element will be compared with each and every element of the list. That means every element of the list should be processed during the execution. Clear? So this one is called linear searching. So let us move with our function. So this is the function to perform linear search. DEF L search ARR item. Okay, so L search is the function name, ARR is an array sent to this function, and the item is the element. Okay, this is the searching element. Then you can check all the elements by using the for loop for I in range len of array. So first the I loop will start from 0 to length. Then if item is equivalent to ARR of I, that means the item will be compared with each element of the array. Okay, if the condition is true, then it will return true. That is, if any of the condition satisfied, then it returns true, otherwise returns false. Clear? Okay, then we can move with our program. So this is our program. So this is the function that we already explained. Then the main function will start from here. So first we define one array ARR. Okay, it's an empty array. The n is equal to input and how many items in list. So first we can read number of elements to be ended. Okay, then for I in range of n, then d is equal to int input enter value. So you can enter the elements, then that element will be added to this array by using the append function. That is ARR dot append of d means this element will be added here. Okay, or it will add at the end of the list. Initially there is no element, so this one will be the first element. Then on next iteration, next element will read and that will be added at the end. Okay, like that this loop will continue till I reaches n. Okay, then you can read the element to be searched, that is int input and the value to search. So the searching element is read into the variable key. Okay, then pose is an element, it's a variable that is equal to linear search ARR comma key. So into the linear search function we send the array and the key. So in this function here the mylist, the variable mylist read the array and the item read the searching element. The n is equal to len of mylist. Okay, then for I in range of n, if item is equivalent to my list of I, so this item, the searching element will be compared with each element of the list. If the condition is satisfied, it will return I, otherwise it will return none. So the returned value will be stored into this variable pose. Then it will check if pose not equal to none. Not equal to none means the element is present in the list. So it will print found at position the pose minus 1. Okay, why this pose minus 1? Because the for loop will start from the 0. That's why the current element should be plus 1. Otherwise, if pose not equal to if pose equal to none means the element is not present in the list. That's why it print not found. Okay, so this is the output. Here list element is 5. Then 10, 5, 11, 28. See children, here we didn't enter these elements in a particular order. You can use a random list. So the enter value to be searched is equal to 20. Then it is present at position 4. So here 1, 2, 3, 4. This is the position. Okay. Then another list size is 6. Here 1, 2, 3, 4, 5, 6 elements we were entered. Then the searching element is 100. This 100 is not present here. That's where we get the output as not found. Okay. Then next, binary searching. Okay, divide and rule. In binary searching, data must be sorted either in ascending or descending order. Okay, then searching start from the middle position. To find middle position, you can use the equation mid is equal to lower index plus higher index. Okay, lower index plus higher index means you will get the size that divided by 2. You will get the middle element. Then if middle value is equal to search element, then you can print search unsuccessful. If the middle element is lesser than the searching element or the searching element is lesser than the middle element means then you need to search or need to perform the same function till the middle element. Okay, if the element is higher than middle element means then you can do the second half. That means when you divide your list into 2, then you can do, if the element is lesser than the half, then you can perform the searching in first half. If the element is greater than the middle element, then you can perform the searching in second half. Okay, if middle value is larger than search value, searching continues towards left of middle position, otherwise towards right of the middle position. Okay, so this method you can follow for ascending order, and for descending order you can do in reverse order. That is at first half, then second half. Okay, then it takes less time compared to linear searching because in every iteration we will compare with the middle element. Then it is suitable for large list. Linear search is suitable for small list and this list is suitable for large list. Okay, so let us check the function. So here the binary search function. DEF binary search. Okay, B search my list comma item. So this list we read from the function from the main program and item is to be searched. Here lower bound low is equal to 0 and higher bound high is equal to len of my list minus 1. Then while low lesser than or equal to high. Okay, so here we are using one while loop. Then mid is equal to low plus high floor division 2. Okay, so to get the integer part we are using this floor division. Otherwise we can use the which one division, normal division we can use. Okay, so to get the middle element it's better to use floor division, otherwise the float in the fraction part will come along with the integer part. So if my list of mid is equivalent to item, so now we get the middle element, then the my list of mid, okay, that element will be compared with the searching element. If the element is found, then to return the mid value, otherwise it checks if my list of mid is greater than item. If the element is greater than item, then you can do high is equal to mid minus 1. Okay, else low is equal to mid plus 1. That is the lower bound and the higher bound values are changed. Okay, my list of mid greater than item means you need to perform the same in the second half. Okay, otherwise return minus 1. So this is the program for binary search. So this is the function and this is the main program. So first we enter how many items to n, then print values in ascending order for I in range of n. Here in the input value ARR of append value. Okay, just like a binary search, linear search we read all the elements. Then key is equal to in the input and the item to be searched. POI is equal to B search ARR comma key. Okay, so all these statements are just like linear search. So let us move to the function. Here my list item high is equal to len of my list minus 1 and low is equal to 0. Then low less than or equal to high. If the condition is satisfied, mid is equal to low plus high divided by 2. Then it will compare with the searching element. If the element is found, it will return mid. Okay, the mid, that position is returned, not the element. Okay, else if my list mid of greater than item, then high is equal to mid minus 1. else low is equal to mid plus 1, otherwise return minus 1. Okay. So let us move with the output. Here number of elements 8, then 8 elements we entered in ascending order and the searching element is equal to 15. Okay, now let us move with the code. Okay, how the execution going on. So here we pass the list and the searching element. So these elements we passed and also searching element 15 we passed into the function binary search. Here lower bound is equal to 0 and high is equal to len of my list minus 1. Okay. Then while low is less than or equal to high, the first condition is false. Sorry, first condition satisfied. Then mid is equal to low plus high divided by 2. Here low is equal to 0, high is equal to 8. Then 8 by 2, 4. Here 0, 1, 2, 3, 4. So the fourth element is 21. Okay, mid is equal to 4 and fourth element is 21. That is my list of mid is equal to 21. The 21 will compare with 15. So 21 is greater than which one? 15. That's why first condition failed and second condition my list of mid greater than item. This condition satisfied. That's why high is equal to mid minus 1. Now the value of mid is equal to 4. 4 minus 1, 3. Okay. So the next value is 15. Clear? 3 means here third 0, 1, 2, 3. So here 15. So again low plus 3 by 2 will get which one? 3 by 2, 1. Okay. Then 0, 1 will check. Okay. Here 0, 1 is equal to 8. 8 is equal to item condition failed. Then my list of mid greater than item condition failed. That's why low is equal to mid plus 1. Okay. So now mid is equal to 1. 1 plus 1, 2. Okay. Then 2 plus 3, 5. Then 5 by 2 will take. Okay. Then we get 2. Here 0, 1, 2. So next element is 12. 12 will be compared with the next element. Searching element. Okay. Again all these conditions are failed. Okay. Then at last it will found the element 15. Like that the processing will going on and find the element 15. Okay. Otherwise if the element is not found it will return minus 1. Clear? So now I believe you all understood the program, how the program is working. Okay. So please copy the program linear search and binary search into your notebook. Okay. Don't forget to copy into your notebook. If you have any doubt, clear your doubts in the live section. Okay children. Thank you.